Hello everyone. In today's session, I'll be explaining a simple assembly code which solves a given expression as shown here, okay, which has both arithmetic as well as logical operations, okay. Let's start with the basics. The very first term you see here is an area, which is nothing but an assembler directive which instructs that specific segment should be given in the memory to store this particular data. EXP is a random name I have given. Code indicates that this is nothing but set of instructions. Read only because we don't want any modification to be happening to this particular code during runtime. Entry indicates where exactly the code is starting. Start is a label, okay, and this is a comment, okay. In this comment I have written what exact operation I want to be carried out in this particular code. Once this particular expression is solved, I want the assembly code to even update the conditional flags. Okay, let's see what exactly is happening here. In the assembly code, register R1 stores the value of A, register R2 stores the value of B, and register R3 stores the value of C. Okay. Now let us see what exactly is happening here. A value is 1, B is 2, C is 3. Now let's see what exactly is the result we'll get for this particular expression. Very first thing that we'll see is A plus B. So what is A plus B? A is R1, B is R2. So R1 plus R2 should be carried out. I'm storing the result of R1 plus R2 in R4. Okay. Next to that, we actually have C into 2. C into 2 is same as adding C 2 times. C in our case is R3. So I am adding R3 plus R3 and I am storing the result in R5. Okay. Next what we have to do is the result of A plus B is subtracted with the result of C into 2. That is R4 minus R5 should be carried out. So I am using the instruction sub and the result of R4 minus R5 should be stored in R6. Okay, this is one more register I am using to store the result. Finally, what we see here is A XOR C. XOR operation, how will you carry it out in assembly? You have this particular instruction XOR, exclusive OR, and that is what I am doing here. A is R1, so R1 content I am XORing it with R3, which is nothing but C, and its result I am storing it in R7. Okay, and then finally what I want to do is I want to perform AND operation between result obtained in this part and result obtained in this part. So this result is nothing but R7 and this result is nothing but R6. So I am performing AND operation between R7 and R6. Whatever result is obtained, I am storing it in R0. So R0 will hold my final result. I am even setting conditional flags using the yes suffix here. Okay, let's see how exactly we'll get the output. Stop, branch, stop. This is an infinite loop. Okay. We can see the very first instruction leads to R1 holding the value 1. Next we have set R2 as 2 and R3 as 3. Okay, let's start with very first operation. R1 plus R2, that is 1 plus 2 should be 3. So R4 value should be nothing but 3. Okay, next what we have is R3 plus R3 should be stored in R5. So our R3 value is nothing but 3. So 3 plus 3 is nothing but 6 should be stored in R5. Let's see if that is happening. Yes. Next what we have is R4 minus R5. So R4 is 3, R5 is 5. So what is 3 minus 6? 3 minus 6 is minus 3, but this is minus 3, in decimal. So what is it in hexadecimal? It is FFFFFFFD. So let's see if that answer is correct or not. Okay, let's take this value. So if you write this in binary, what is the answer you will get? Okay, this is it in binary. How will we obtain its actual value from this particular signed hexadecimal value? First we have to find ones complement of that. What is the ones complement of this? For this value, this is nothing but ones complement. We have to add +1. So what's the answer there? You will get it as all zeros, just the last part will become 3, 0, 0, 1, 1. Okay, so for this particular number, actual decimal value is -3. Why minus? Because MSB bit is 1, so immediately we know output is minus, and then we have to find ones complement of this and add +1 to obtain the actual value, which is 3. So as expected, the subtraction result is -3, which in signed hexadecimal is this particular value. Okay. Next, what should happen is we have to perform XOR operation between R1 and R3. So what is R1? R1 is 1. Okay, so all remaining values are 0. So let me just put dots here, and R3 is 3. If you perform XOR, what should be the answer here? 1 and 0. Okay, because in the case of XOR, only complementary values output will be 1. So this is nothing but 2. Okay, so here next step that we have is nothing but we have to perform AND operation between R7 and R6. First let's carry XOR operation, then we'll go ahead with the next step. Okay, so we got R7 as 2. Now we have to perform AND operation between R7 and R6. So what is R6 value? R6 is all 1 except for the last part. Okay, and R7 is nothing but 2. All this value will be 0. So when you perform AND operation, what's the result you will get? 0, because in no place you will have a common 1. Okay, so 0 is the result stored in R0. Because you're setting the conditional flags, what should be the result in CPSR? Z flag should be set as 1. Okay, let's see if that is happening. Yes, Z flag is set as 1 and R0 is nothing but 0. So the result of this particular expression is 0, and because we even had to find how exactly it affects the conditional flags, Z flag is set as 1. Okay, so this is how you solve a simple expression which has both arithmetic and logical operations.